So this is our video lesson for the Unit 4 review. I just wanted to re-emphasize to you all to please make sure that you are listening to the dialogue in this as well as watching. There's large parts of like the explanations that are spoken and not necessarily transcribed, so or written down. So it's really important that you're listening to the explanations for some of these things. You are welcome to fast forward if you got a question right and you understand it and you could do it no matter how it was phrased. You're welcome to fast forward. Okay. But I do try to show a few different ways to solve each of these questions. The first few questions talk about if something is or is not a function. And this is just a reminder, to be a function, each x must map to exactly one y. Each input has exactly one output. So here's some examples of some functions. Just to go over what is not a function, if I look at this set of ordered pairs here, -1 has two different outputs, 5 and 2. So if I were going to explain why this is not a function, I would say the input x equals -1 maps to more than one output. Okay, so not a function. Same thing in this table. You've got 3, an input of 3 that maps to 4. That same input of 3 mapping to 6, no good. Okay, so the input of 3 maps to more than one output. For graphs, you can use the vertical line test. And you are more than welcome to say that this graph is not a function because it fails the vertical line test. This graph is a function because it passes the vertical line test. If you were to draw a vertical line through this graph, it would only hit it at one place. If you drew a different vertical line, it only touches the function once. If we look at the graph of, say, something that looks like, let's say, an S shape, if I draw a vertical line right here, it hits the function at 3 different spots. So this X value, this input, has 3 different outputs. So it is not a function. It fails the vertical line test. Same with this mapping. 5 maps to 2 different outputs. So it is not a function. That is not to be confused here. 7 has 1 output. It's 2. 10 has 1 output. It's 2. It's okay that they're both the same. As long as 7 just maps to 1 output and 10 maps to 1 output, we're good. The fact that 5 maps to 2 different outputs is what makes this second example not a function. So again, just quickly, it says explain how it's, explain if it's a function or not. Case 1 is 1 has 1 output, 3 has 1 output, 6 has 1 output. It does not matter what the outputs are, okay? It's just, does each X go to 1 output? So case 1, yes, that is a function. And again, these answers are on the second to last page, so you can see them in more detail if you need. Case 2 is not a function. 0 has 1 output. The problem is 9 maps to 2 different outputs. So that relation is not a function. Oops, I missed one. Here's number 2, which is a function and which is not. Explain your reasoning, okay? So if I look at relationship A, if I draw a vertical line through this, it hits the function more than once. So relationship A is not a function. It fails the vertical line test. Relationship B, if I draw a vertical line and then I proceed to move that vertical line along my function, it never hits the function more than once in any given spot. So relationship B is a function. It passes the vertical line test. Each input maps to exactly one output. Number 3, as a large truck fills its gas tank, the volume of gas in gallons can be modeled with this linear function, where V is the volume of gas and M is the number of minutes. State the meaning of the slope and the y-intercept of this function with respect to the volume of gas associated with the number of minutes it has been filling. So I've got my equation. One of the questions that I asked some of the students here after school was, what does a linear function typically look like when we're asked to find the slope and the y-intercept? And they said, well, it's usually y equals mx plus b. So what I can see here is that instead of x, I've got my variable m, okay? But the number in front of the x is my slope. So 4.8 is going to be my slope. Now we'll talk about what that means in a minute. B is your y-intercept. It's where you begin. It's the constant. So that's going to be 8.2. So the y-intercept is going to be 8.2. Now we have to think about what this is measuring. So if I were to set up a table for this, okay, so here's different m values and different v values. Where do we typically like our tables to start? We typically like it to start at 0. So I'm going to go ahead and pull up my calculator. And I'm going to open a new document. And what I want to do, I have the function. I know I want m to be 0. So I'm going to take 0 and I'm going to store it as m. Oops. Okay. Then I'm going to go ahead and I'm going to enter this function and see when m is 0, what do I get for my output? Now, I think what I'm going to have to do here is do the handheld only. Okay, perfect. That's helpful. So I'm going to type in 4.8 m plus 8.2 and see what I got. And I end up with 8.2. And that right there is my y-intercept. So what does that mean? What's the 0 measuring? What is m measuring? Well, m is minutes. V is volume of gas. So what does the y-intercept represent? When, actually, let's say instead of when, let's say at 0 minutes. The volume of gas is 8.2. And what are we measuring it in? 8.2 V is the volume of gas in gallons. So before we even started to fill up the gas tank, we had 8.2 gallons of gas in there. That's what that y-intercept means. So now I'm curious, well, how much gas is going to be in there after 1 minute? So now I'm going to take 1 and store it as m. And now I'll do 4.8 m plus 8.2. And what I end up with is 13. And then I can do the same thing with 2 if I want. So I can take 2, store it as m, If you want to save yourself some time, you can come back up and grab that and hit enter, and that gives me 17.8 gallons of gas. So now the second thing they want to know is the slope. Well, the slope is 4.8. Where do I see 4.8 in my table? When we talk about slope, we talk about change in y and change in x. So let's see how the table is changing. Well, my m's, my minutes, are going up by 1. My gallons of gas, if I do 13 minus 8.2, let's see how much that increased by. Well, that's weird. It went up by 4.8. From 13 to 17.8 is another 4.8. So my slope is 4.8. Remember, slope is a rate of change. So the rate of change of the volume of gas is 4.8 gallons. Now, what are we measuring it? It goes up 4.8 gallons every what? Well, every 1 minute. So per minute. You could also say gas is being added to the tank at a rate of 4.8 gallons per minute. So you have a lot of different ways to talk about this, okay? The important thing to know is your y-intercept is where you begin. When m was 0, we had 8.2 gallons of gas. Your slope is the rate of change. We are increasing the amount of gas by 4.8 gallons per minute. Okay, let's look at 4. Determine if each table represents a linear function. A linear function means it has a constant rate of change. So when I look at my table, from -1 to 2 is an increase of 3. From -7 to 8 is an increase of 15. So if I do change in y over change in x, I'm going to get 15 over 3, which is 5. So I know the rate of change between these first two sets of points is 5. Now I'm going to do it from here to here. 2 to 3 is an increase of 1. 8 to 13 is an increase of 5. Change in y over change in x is 5 over 1. That's also 5. This is looking linear, but let's just double check. 3 to 5 is an increase of 2. 13 to 23 is an increase of 10. Change in y over change in x, 10 over 2 is 5. And just to double check, 5 to 8 is plus 3. 23 to 38 is plus 15. That is still a rate of change of 5. So A is linear. Okay. Now, if I want to write the equation for this, I need to figure out where my table is at 0. So I know the closest I can get to 0 is here at -1. So I know at -1, it's at -7. I don't know where it is at 0. I don't know where it is at 1, but I know at 2, it's at 8. And we said the rate of change is 5. So that means from here to here, it's going to have to go up 5. So that's -2. Here to here, it goes up 5. That is 3. And then here to here, if it goes up 5, that gets me to 8. So now I know my equation is y equals, where does it start? Your y-intercept is when x is 0. So it's -2. And then my slope is 5. What am I doing over and over again? I'm adding 5. Since I'm adding it over and over again, I include an x with it. So there's my linear equation. Okay, B, let's take a look at this one. I'm going to switch to green. From -3 to -2 is +1. From 10 to 7 is -3. Change in y over change in x would be -3 over 1, which is -3. From -2 to 0 is +2. From 7 to 1 is -6. Change in y over change in x, -6 over 2 is -3. So far, it's looking linear. From 0 to 2 is +2. From 1 to -8 is -9. Oh, wait a minute. -9 over 2 is not -3. This is not linear. It does not have a constant rate of change. Yes, the rate of change between these first few sets of points was constant, but then it started to get messed up here. You have to make sure that that rate of change is constant throughout the entire table. So don't be fooled and check the first two and then fall for the trick here. Okay? It is not linear. There is no constant rate of change. Okay, let's go to the next one. Write the equation of the line in y equals mx plus b form that passes through the points -2, -15, and 5, 13. So we said there were two forms of a line. There's y equals mx plus b, and there's y minus y1 equals m times x minus x1. I'm going to choose to use this one because I know 2 points. I don't know a y-intercept. So the first thing I'm going to do is I'm going to organize my points in a table and get my slope. So my first point is -2, -15. My next point is 5, 13. To go from -2 to 5, I have to add 7. So my change in x is 7. To go from -15 to 13, I have to add 28. So my change in y is 28. My slope is change in y over change in x. 28 over 7, which is 4. So now I know my m value. So I'm going to have y minus y1 equals 4 times x minus x1. Where am I going to get an x1 and a y1 from? Well, I get to pick either point. So it doesn't matter which one I use. If we use -2, -15, I would strongly encourage you to put x1, y1 underneath them. So this would be y minus y1 is -15. Well, what happens when I have a double negative like this? It becomes a positive. So that's y plus 15 equals 4 times x minus -2. Well, minus a negative is plus. So here's the equation of my line. Now, if you use this point, you'll get y minus 13 equals 4 times x minus 5. It wants it in y equals mx plus b form. So the only thing that I've got left to do here is I'm going to get y alone. So I'm going to start by distributing the 4 over here. So I've got y plus 15 equals 4x plus 8. Then I'm going to subtract 15 from both sides. And I get y equals 4x minus, I think it's 7. Okay, so there it is in y equals mx plus b form. My y-intercept is -7. My slope is 4. It increases by 4 each time. Let's say you use the other point and got this equation. Let's see what happens when we get y alone here. So y minus 13 equals, I'll distribute the 4x minus 20. So now I'm going to add 13 to both sides. And I end up with y equals 4x minus 7. Guess what? Regardless of which point you use, you get the same thing. Okay, let's look at number 6. People are entering a stadium at a steady rate of 32 people per minute. When the gates open, there are already 46 people in the stadium. No one leaves the stadium for the first hour. How many people will be in the stadium 30 minutes after it opens? Show the calculations that lead to your answer. I'm going to start with a table because this is looking a lot like a table to me. It says when the gates open, there are already 46 people. So at 0, when I start, there are 46 people. This allows me to go ahead and say that my y is people. What are we measuring x in? When the gates open, there are already 46 people. Let's go to the next point. So if I take x and increase it by 1, what's going to happen? Well, it tells me people enter the stadium at a rate of 32 people per minute, which means when x goes up by 1 minute, my y value must go up by 32. So that's going to give me 78 people. When another minute goes by, this is going to go up by 32 again. So 78 and 30 is 70 and 30 is 100. So is this 110? Let's just double check that. It's been a long day. 78 plus 32, 110. Okay. I just want to make sure. So now we want to figure out how many people will be in the stadium 30 minutes after it opens. Well, this looks like a good job for an equation. Y equals, where am I starting? I'm starting with 46 people, and I am adding 32 people over and over again per minute. So for 30 minutes, that means I'm trying to figure out when x is 30, what's the y value? So 46 plus 32 times 30. And this we'll go ahead and do in our calculator. Oh, wow, that's 1,006 people. Okay, so show the calculations that lead to your answer. There it is. Part B, write a linear equation for the number of people n as a function of the time in minutes m. Number of people n as a function of m. N of m equals. And good news, I actually already have it written here. So it's going to be 46 plus 32, but instead of x, my independent variable is m. So if I told you n of 2 equals 110, I want you to think about what that means. 2 is the number of minutes. So after 2 minutes, there are 110 people in the stadium. N of 30, we just found above, was 1,006. After 30 minutes, there were 1,006 people in the stadium. Okay, 7, graph each of the following lines on the grid below. This you should be able to do with your calculator. Okay. I'm going to do these together with you just to make sure you're good. Again, you can fast forward if you need. In the first line, the y-intercept is -2, so I'm going to put a point there. Slope is what is in front of x, so that's a 1. as a fraction, that would be 1 over 1. So I'm going to move up 1, forward 1, up 1, forward 1. And I'm going to go ahead and plot as many points as I can to be as accurate as possible. You can also do this using your calculator. And you can go ahead and connect those. Because there's so many lines on here, I would make sure you sign the line. Second one, y-intercept is 5. So it starts up here. My slope is negative. That means I go down 2, forward 3. So down 2, forward 1, 2, 3. Down 2, forward 1, 2, 3. Down 2, forward 1, 2, 3. And I can go ahead and connect those. Ideally, you would put another few points on there, but this will do. Y equals -4. There's no x in this. So this means in my table, y is going to be -4 no matter what. So if x is -2 or 0 or 10, y is going to be -4. So that's going to be a horizontal line. The last one, x equals -2. I'll do this one in gray. Again, there's no y in this one. There's only x. So x is -2 always, no matter what y is. So if x is always -2, -210 is there, -20 is here, -2 is here. That is a vertical line. If you're struggling with how to graph that, we did that in class today. I just want to review that quickly. If I go down to my graph and select it, I can hit delete and go to relation. Because y is not alone in that last equation, I have to type in x equals -2. If I hit enter, it gives me that vertical line. And again, because it's a vertical line, it is not a function. Oh, and you know what? I forgot to label that. This guy is x equals -2. So there's our lines. Okay, multiple choice questions. Please use your calculator because this will prevent you from making mistakes. Okay, I'm going to just try to move this. Oh, it doesn't like to get moved to the side here. Oh, that's not bad. Okay. So they tell me f of x equals -2x squared plus 3. When we see f of x, it always makes me think of a graph. So I'm going to open a new graph page and I'm going to type this in. -2x squared plus 3. I'm going to hit enter. Now, if I want to find f of -3, this -3 is your x value. So you have 2 different ways you can do this. You can go to menu, trace, graph trace, and then type in -3 and hit enter. And we see down in this bottom corner that when x is -3, y is -15. The other thing you can do is hit Control T to get a table and scroll up to -3, and you can see the output is -15. Which of the following is not a relationship where y is a function of x? So which is not a function? So again, you've got to look for an input that goes to more than one output. And in choice 2, I see -2 mapping to 4 and -2 mapping to -4. That is not a function. So again, reading carefully so you know if they're looking for what is a function or what isn't a function. Okay. Watch out for choice 3. -2 goes to 5 and 2 goes to 5, but that's okay. The input of -2 has one output 5, and the input of 2 has one output, which is 5. So that is okay. 2 does not work because -2, the input, has more than one output. So this is no good. This is okay. Number 10, Jenna is selling glasses of lemonade for $1.50 per cup. She begins the day with $4.50 and change. The amount of money M she has is a function of the number of cups she sells. Is M equals 150C plus 450? Which of the following could be an appropriate domain? Domain is your inputs, your X values. In this case, your C values. C is cups. So the question is, when I'm looking at this, could she sell -3 cups of lemonade or -2 cups? Last time I checked, we can't give cups to a lemonade stand. So I don't think that's going to be possible. Let's look at 2. Could she sell 1 cup? Yes. 1.5 cups? I'm not sure. Nothing up here says that she's going to sell whole cups, part cups. So let's keep that one just in case. 3. Could she sell 0 cups? Yes. 1 cup? Yes. 2 cups? Yes. 3 cups? Yes. This, I think, is going to be the best one. Number 4, they're trying to trick you. This is not the domain. Number 4 is the range of this function. If she doesn't sell any cups, she's going to have $4.50. If she sells 1 cup, she'll have $6. 2 cups, she'll have $7.50 total, and so on. Okay, so we can eliminate 2 because nothing up here says she's going to sell a part of a glass of lemonade. Which of the following represents the range? The range is the Y values. So remember, you're looking bottom to top. Whoops. So if I look at the lowest point of this function, it's down here. That's at -1, 2, 3, 4. So it looks to me like it starts at -4. The highest point this function goes is up here, which is 1, 2, 3, 4, 5. Now the difference, I can get rid of these. Those are my range. I'm sorry, my domain. This asks for range. The question is, which of these 2 is it? Well, it has to do with this open circle right here. Since that's an open circle, my function never actually hits -4. It gets really close, but it doesn't get there. Up here at 5, it's a solid circle. So 5 is included. So that the answer for my range would be choice number 1. 12, given the graph of h of x shown below, over which of the following intervals is h increasing? Remember to find where it's increasing or decreasing. You have to look at it from left to right. So as I trace the graph left to right, right here, it's going down. This is decreasing. Here, it's going up. That is increasing. Here, it's going back down. That is decreasing. So if I want to know where it's increasing, it's this piece I'm looking for. So this is where it starts increasing. This is where it stops increasing. It's increasing between these 2 x values. So what are those x values? Well, here's your origin. So this would be -1, -2, -3. So it starts increasing at -3. It stops increasing here at 1. X is in between them. Okay, so that would be choice number 2. Which of the following points lies on the graph of this line? Well, let's graph it. Okay, I'm not going to spend a bunch of time trying to plug these things in. We've got a nice tool for this. Open a new graph page. It's y equals, so I'm going to keep it f of x equals 5x minus 2 Okay. Now, if I want to know the points that are on here, I can press Control T to see the points. The first point is 0, 4. So if I go up to 0, oh, nope, that's not in my table. So it's not 0, 4. 2, 8. Oh, look at that. That's there. I want to make sure the others aren't, just to make sure. Negative 1, 2 is not, and 4, 10 is not. So it is 2, 8. Okay, which of the following is the equation of the line graphed below? First thing I'm going to look at, my y-intercept is 1, 2, 3, 4, 5, 6. It's up here at 6. So I know I'm going to have y equals mx plus 6. So that eliminates 1, 2, and 3. I think it's choice 4, but let's make sure. How do I know my slope is negative 2? Well, how do I get from this point to this point? This side is 2. This side is 1. Change in y over change in x would be 2 over 1. The reason it's negative is this line is decreasing as I read it left to right. Okay, how else could we do this? Well, you could graph each of these. Put them in your calculator. See which one gives you the exact same graph with the exact same points. So you have a lot of different options. Besides just your y-intercept, you could say, well, it's decreasing, so the slope has to be negative, therefore it can't be 1 or 3. And then you could do a process of elimination from there. A cell phone plan charges a flat monthly fee of $15.25. Ooh, that sounds like my y-intercept. It starts at $15.25 and an additional 7 cents per minute. Oh, no, just kidding. Per hour. This is a great deal. While talking on the phone. Which of the following functions gives the cost C of the cell phone plan as a function of the number of hours we're talking? Well, I just wrote that down. It's this guy right here. So as you're reading, jot some things down and it might help you to see which answer choice makes sense. What's the slope of the line that passes through -3, 5 and 115? Also, if they asked you about the average rate of change, this is also like finding the slope. So I'm going to put my points into my table. Change in x from -3 to 1 is an increase of 4. Change in y from 5 to 15 is an increase of 10. Change in y over change in x is 10 over 4. And I can reduce that. If you want to do it in your calculator, you can. So again, I can come back, pull a calculator page. 10 over 4, enter. I get 5 over 2. That is answer choice 4. Okay. If a line is drawn parallel to the x-axis through the point 4, 2, then its equation would be what? The key to this is parallel to the x-axis and through the point 4, 2. So the point 4, 2 is here. Here's your x-axis. So if it has to be parallel to the x-axis, it has to be a horizontal line. So what I can see is if I make a table for this, when x is 4, y is 2. If I go back here, when x is 3, y is 2. Back here, when x is 2, y is 2. When x is 1, y is 2. When x is 0, y is 2. And I think, like, even if I go all the way out to -10, it's going to be 2. So what equation will represent this? Well, y equals 2. It's a horizontal line. Okay, 18. A line with a slope of 5 passes through the point 3, 8. Which of the following is the value of its y-intercept? So I'm given a slope and a point. So I'm going to do y minus y1 equals m times x minus x1. My slope is 5. So I'm going to replace m with 5. X minus x1 is here. It's 3. And then y minus y1 would be 8. So now if I want to know the y-intercept, I've got to get it in y equals mx plus b form, which means no parentheses and y is alone. How do we get rid of parentheses? Well, we distribute. And then how do we get y alone? We add 8 to both sides. Negative 15 plus 8 is minus 7. There's my y-intercept right there. Okay, the last page is part of your February break assignment. So it says, which of the following is an example of a rational number that is not also an integer? So rational numbers, just to review, are all the numbers in this circle here. Everything inside. Natural numbers, whole numbers, integers, fractions, decimals that repeat. So 9.45, it repeats. Decimals that end. Okay, those are rational numbers. So which is an example of a rational number that is not an integer? Well, what's an integer? Integers are positive and negative whole numbers. So if it's not an integer, it can't be 2 or 4. The question is, which of these two are rational but not an integer? Well, one of these is an integer in disguise. So let me use my calculator just to see if I can figure out what these are. Choice 1 is 10 over 2, which is 5. Oh, wait a minute. That is actually an integer. 8 over 3, let's just double check what that looks like. So 8 over 3, I'm going to go ahead and click Control Enter. Ooh, that is 2.6 repeating. That is not an integer. It is rational though. Which of the following is the decimal representation of this rational number? So I'm going to go ahead and put this in my calculator. So I'll do 35 over 303, and I know it's going to be a decimal, so I'll hit Control Enter. Ooh, that's interesting. So it's 0.1155, 1155, 1155. So which of these shows 1155 repeating over and over again? Choice 4. What's the value of the square root of 36 plus 2 radical 25? Well, the square root of 36, let's see if that comes out to be a nice number in my calculator. If I type in the square root of 36, I get 6. Well, that's a lot easier. Then 2 radical 25. I'm just going to type that whole thing in and see what I got. 2 radical 25. Oops. There's an error here. 2 radical 25. Enter. 10. Oh, so this is really 6 plus 10. That's also known as 16. It's 3. So this is a rational answer. Okay. 3 radical 20 is equivalent to, so let me type this in. 3 radical 20. Ooh, that's not a nice number. So it's not like number 3 where I could simplify it nicely. So I'm going to have to do some work here. So this is really 3 times the square root of 20. I've got to break 20 down. 20 breaks into 4 and 5, or 2 and 10. It doesn't matter. And 4 breaks into 2 and 2. So I can rewrite this as 3 times the square root of 2 squared times the square root of 5. This can be simplified. The square root and the squared cancel, so we get 3 times 2 times radical 5. 3 times 2 is 6. So this becomes 6 radical 5, which is answer choice 4. Now to make sure it's the same, I'm going to type in 6 square root of 5 and hit enter. And I get that it's 13.41. It matches. Okay. So if it's multiple choice, you could plug in your answers and see which one gets you the same decimal. Number 5, if f of x equals, well, look at this. We usually graph these. So let me go ahead and go to my calculator. I'm going to open a new graph page so I don't get mixed up here. And I'm going to type in 10 minus the square root of x plus 4. Enter. Now, I can't see the graph, but let me go back to the problem. It wants to know what f of 12 is. Remember, f of, this is your x value. So when x is 12. So I could do Control T and go to my table, and I could go down to 12, and I get 6. There it is. Which of the following is an irrational number? An irrational number means a decimal that does not repeat or end. So 8/3, that's rational. It's already a fraction. -5 is an integer. That's rational. Okay. Just to go back a minute, if I type in 8/3 and hit Control Enter, I end up with this decimal, 2.6 repeating. So that's 8/3 is 2.6 repeating. That's a repeating decimal. Therefore, it is rational. 3, I want to go ahead and enter in my calculator and see what it is. So I'm going to put a square root. Inside the square root is a fraction. When I hit enter, I get 2/3. 2/3 is a fraction, so it's rational. But just in case you're not 100% sure, you can hit Control Enter. 2/3 is 0.6 repeating. That's a repeating decimal. It is rational. And the last one is the square root of 10. If I type that in, I get a long decimal. It doesn't repeat. It doesn't end. Choice 2 is the irrational answer. Which of the following results in an irrational number? This is one, again, you're going to be putting these into the calculator. So number 1, 3/2 plus the square root of 1/25. 17/10, that is rational. Okay, so you're going to keep going through and figuring out which one is rational, which one's irrational. 8, which expression below is equivalent to 12/radical 3? Well, remember, I want to get rid of the radical in the denominator. So I'm going to multiply the top and the bottom by radical 3. This gives me 12/radical 3 in the top over radical 3 times radical 3 is radical 3 squared. The squared and the radical go away, so I get 12/radical 3 over 3. The problem is that answer doesn't show up there. So what in the world is going on? Well, we must have to reduce this. 12 can be rewritten as 4 times 3. So this is really 4 times 3 radical 3 over 3. Those 3's divide out, and I just end up with 4 radical 3. Which of the following is the result of the difference of 5 radical 8 minus 3 radical 2? So I'm going to need to reduce this. So I'm going to start with radical 8. 8 breaks down into 4 and 2. 2's prime. 4 breaks into 2 and 2. So for 5 radical 8, we've got to be very purposeful here. This is 5 times. Radical 8 can be rewritten as the square root of 2 squared times the square root of 2. 2 squared and the square root cancels, so we get 5 times 2 radical 2. 5 times 2 is 10. So 5 radical 8 became 10 radical 2 minus 3 radical 2's. Well, 10 radical 2's minus 3 radical 2's, 10 minus 3 is 7, so it's 7 radical 2's. And that's the end of the review. Okay, just a reminder, I will be after school tomorrow until 4 o'clock, so come in if you need any help reviewing. Thanks so much. Bye-bye.